right. And thank you, Ryan. Thanks for organizing LoopConf. It's obviously a great developer conference. All right, so let's get into it. So I'm going to talk to you guys today about refactoring the disaster that no one's talking about. So I'm going to talk about it. And how we're handling JavaScript tech debt in WP Migrate DB Pro. And you can see we have a nice dumpster fire here. This is kind of how I feel about legacy JavaScript and how it fits in with modern JavaScript and all the cool stuff that we get to do now. So a little bit about me. As I mentioned, or as Ryan mentioned, I work on WP Migrate DB Pro for a company, Delicious Brains. Delicious Brains does WordPress plugins and services. I'm from Canada, so I'm kind of used to this cold weather, but I'm ready for winter to be over at this point of the year. And this is my first conference talk, believe it or not. So if you have any feedback or you find my conference boring, please don't tell me. All right. So WP Migrate DB Pro, hands up if you're a customer, have you used the plugin before? Cool, lots of hands, awesome. So kind of does exactly what the name suggests. It'll migrate your database between two WordPress sites. We have add-ons for the media files, for multi-site migrations, as well as the CLI. And we're working on a themes and plugins add-on, which will allow you to migrate those as well. So that's kind of what's in the pipeline. So a little bit of an outline of what I'm going to talk about, what I'm going to cover, what technical debt is and what some of the symptoms are. It's kind of my experience working with WP Migrate DB Pro and how that came about. So we'll talk about understanding the code, right? So before we actually get into changing anything, we want to get a good understanding of what the baseline is. And then we'll talk about getting some unit tests or some kind of tests in place so that when you do get into the refactoring, everything doesn't blow up and your customers are angry at you. So what disaster? What's the disaster that I'm talking about, right? It's kind of a sensational title. Well, I kind of alluded to this already, but it's this legacy JavaScript that we all have to work with. When I was thinking about what I wanted to talk about, I was thinking I definitely want to talk about JavaScript because I'm really into that right now. And I was thinking about like React and Vue and Angular and all these fun things that we get to work with. But then I was like, nobody's really thinking or talking about all this legacy stuff we got. And when we think about a few years ago when we were doing JavaScript development, kind of the big thing on the market was jQuery, right? And it still is. The problem with jQuery, though, is that it doesn't enforce any kind of convention or any kind of sort of style that you have to write your code in. You can end up with these script files that just have a bunch of kind of disorganized jQuery statements, really. They're not even functions in a lot of cases. So it kind of works with the DOM directly, and you don't have a lot of organization. Like now we have these ES 2015 classes, and we have these modules with CommonJS and that kind of thing, right? So we can do all these fun things. But this old code doesn't work like that. So I was trying to think about how we can work with that and how can I work that into a talk. And of course, we have a term for this, right? This old code that we made these decisions about, and that's technical debt, right? And basically, it's this idea that you go with the easy, quick solution, right? The jQuery module or the including a script file versus like a better solution that would work maybe a little bit better organized and take a little bit more time, but we go with this easy solution, and that's what technical debt is. From my understanding. And it has this concept of debt, right? So everyone's familiar with what debt is, right? When you're in financial debt, like you have to pay it back. And the same kind of idea with code debt or technical debt is that you have to at least deal with it. You don't necessarily have to pay it back, but you have to go back and at least address it in some way. And I know like everybody was talking to a few of you earlier about technical debt, and like everybody's got technical debt that they have to work with, and it's kind of a common thing. For us on WP Migrate DB Pro, we have like a 3,100 line script file, right? This is one of our script files, so like our IDEs will freeze when we're loading it up, and like GitHub takes like a second sometimes just to render the page. And you can forget like loading up any diffs or anything like that. That just blows up GitHub. So let's look at some examples of our code, and you can kind of see what I'm talking about. So this is a function that we have. This is kind of the button click event that kicks off the whole migration process. It's just standard jQuery function, but you might notice some weird stuff going on here. So we have this doing Ajax variable. Doing Ajax isn't defined here. This is like a global variable, mystery variable defined somewhere. And it's toggled, right? So we set to true, and then inside a success function, you can kind of see here, set to false, and then it's set to true again. Again, not really all that sensical. It's hard to kind of figure out what's going on there. Kind of like a state management variable. And then we have this functions declaration, which is actually a brand new function. It just shows up in our success callback, right? So obviously that doesn't need to be there. That can be pulled out to a higher level for sure. So how does this happen? How do we get to this point where our code is all these nested and kind of nonsensical bits that are together? And the great thing about Git and GitHub is you can find out how it got like that, right? You have this history that you can look at, and it's this idea, right? This easy solution, fitting this extra if clause or this extra block in just to kind of fix a certain use case or bug that comes up, right? So when we're talking about small bits, it's not a big deal, but when you look at a large file and you're talking about 3,000 line script file, it can make you scream and pull out your remaining hair. So we kind of went over this already, but we have some symptoms, right? So symptoms of our technical debt: long functions, right? Really long script files, deeply nested functions in code. The only one who can ever change his code is Pete effect, right? Like there's only a single developer that knows what's going on. And if he leaves the company, then what are you going to do? And we'll talking about global variables and functions, right? Kind of talked about that already, but how that can lead to your technical debt as well. So let's see what we can do. What can we do to put out that dumpster fire? Can we extinguish that fire? So we'll get into some of the tactics we have here, but we want to set some goals up. And something that I discovered with trying to refactor the JavaScript with Migrate DB Pro is that if you don't have these goals up front, you can end up just kind of spinning your wheels and fixing little syntactical things, and you're not really pushing anything forward. So what's really important, I wanted to mention up front, is having these goals. So you want to reduce the bug fix time, right? So for us as a product company, we're definitely looking about speed. If you have these new projects or you're working at an agency, you might have different goals. But for us as a product company, we want to work on things like reducing our bug fix time and reducing our time to create new features and get new releases out, right? Those are the kind of the big things for us. And we're going to talk about refactoring versus rewriting the entire application, which may be an option for some people, or waiting to rewrite everything. The problem with that is that bugs you've squashed over time in your existing code tend to come back, right? And this is something that can happen when you're rewriting from scratch. So just something to consider. So the first thing, before we actually get into doing anything, we want to understand the code. And this is kind of an important step that I kind of realized needed to be added, because if you don't understand your dependencies and your how things are relating to each other with loading your files with your onQs or your script tags, you can end up with these race conditions. And that's definitely something that I ended up dealing with when I started to get into a bundler, because the bundler will put things in the order that it thinks should be, but if you have something defined that's defined before or after, you can end up with these messy situations. And we don't actually want to change anything yet at this point. We want to just make sure we get a good grasp on the code and figure out what's going on there. And if there's any easy fixes or syntactical fixes, this is a good time to find them, right? And I find with JavaScript in particular, it's great to use a linter, right? So kind of the most popular linter these days is ESLint, obviously. And the thing about ESLint is it's great because you can use these minimal rule sets. You can set up the rule sets based on how disastrous your code is, and then you can go through there and you can see we have console log statements that are added in our code. We have these variables that are defined but never used, all these types of little things that can add up when you're refactoring. ESLint can kind of point all those out for you. So that's kind of a good first step if it's in a really bad way kind of thing. And this is actually running off of a Webpack watch mode. So it's running every time everything gets built or get rebuilt, you have this statement from ESLint coming out. So that can be helpful. And then the next thing you want to do is you want to get into this testing stage, right? And the thing about testing with JavaScript is it's notoriously difficult, or it can be with legacy code. So in my experience, trying to get unit tests in particular working with jQuery code is kind of a method in making yourself go insane, right? Because jQuery by default works by these side effects, right? So jQuery, you have these statements, and it's whether it's a click button or whatever, and it's going to update the DOM over here. But you don't have it necessarily wrapped in a function with your input parameters and your return statements like you would require for a unit test, right? A traditional unit test. But there is some things you can do. So I tried to get Mocha running with our existing code base, and I tried to figure out what it would take just to get a couple unit tests running, just on all legacy code as is. I haven't modified anything yet, but just to see if I can get a couple green check marks, right? That's what you want to see when you're running Mocha, right? So you want to get a couple check marks. So to get to this state, right? Keep that in mind. Now we're in. This is what you need, and I don't expect you to be able to read that, but you can. That whole block of code minus that red box right at the bottom. All the rest of that is just boilerplate, right? And the reason being is that if your legacy code is heavily reliant on the browser, you have to mock all that stuff out, right? You have to mock out your browser. You have to mock out jQuery if you're using it. What's the window object, right? And a lot of the times your unit tests will be running in a Node.js context, right? So Node.js doesn't know about any of these things that are in the browser. So it's a lot of work. It's definitely something you can do, but there's other options that we have. So this is an example of headless Chrome running. And headless Chrome is awesome because, well, it's just awesome. But it comes with the Puppeteer library. And the thing about the Puppeteer library is it allows you to script a browser, right? So you can use Puppeteer to log into WordPress, go to the Migrate DB Pro page, and from there it'll actually run a migration. And the thing about Puppeteer is it allows you to actually script it. This is obviously running in a non-headless mode, but you set a flag to show it. And with Puppeteer, you can actually integrate with Mocha, right? So you can expect your UI to render in a real browser, like in a Chrome instance. It can render your page, right? And then what you can do is you can use these expect statements in Mocha, right? Common kind of straightforward Mocha stuff. And then you can see like a text on my page is equal to this, and you can do all these types of statements with chai and that kind of thing. And with Puppeteer, you get this page object. And the page object is cool because there's a lot of functions on there to manipulate the DOM directly, but you can use this evaluate function, which is kind of one of the key functions to use when you're testing, because what you can do is run your JavaScript in the browser context, right, rather than in the Node.js context, and then you can pop it back into Node and you can do all your tests with it, right? So that's something I discovered is really helpful when you have this legacy code base, just to get a base level of testing in place. So the next thing we'll go over is refactoring. Right? And refactoring is really what the core thing you want to do at the end. So we have an understanding of the code and how it all relates together. And we have our tests in place so that if we break stuff, our tests will fail. At least that's the plan. So now we'll get into doing refactoring. And refactoring, as that common statement is, right, changing the engine of the plane while it's still flying, right? And that's kind of the main idea behind refactoring. We don't want to actually change things so that the UI is broken for our customers. We want to keep the UI the same, but we want to make the code a lot easier to work with and to iterate more quickly, right? So we'll talk about globals and how the value of this can change depending on the context and what code's calling it. I'll talk about some code splitting stuff, right? So we'll get into using bundlers and how those can be used to kind of break apart these nasty things and put them back together for you. And then we'll talk about a couple new JavaScript things that I found are really helpful refactoring some of the legacy stuff that we have. So I love this tweet from Ben Halper. Now, he's the developer of dev.to, and I love this quote because it's really, when you're talking about the this keyword, right? I mean, I've come across it. This is the exact thing I came across, right? So we're going to go through some example, and a specific example that I found in our code base. And it's going to be a quiz, so there's going to be three questions, so you can mark your score. All right. So question 1. You don't really have to understand this code, but this is WPMDB call next hook, my friend. And somebody decided when the code base was first written that emulating WordPress's hook system in JavaScript was a good idea. So this is part of that. And basically what it does is there's an array of functions, global array, global variable functions. And then what this does is it pops one off and it calls it with JavaScript's call, and it passes the value of this. Now, what is the value of this? This is a global function. Top level. Does anybody know? Just yell it out. Window. Window it is. There we go. Mark your scores. All right. That was the softball. Okay, next one. Same exact function, but ustrict. So ustrict is this funny little string that gets injected by some frameworks, some libraries, bundlers. That's what caught me. And it invokes browser strict mode. I don't fully understand browser strict mode because it's a little bit weird, but what it does is it coerces and forces things to be false or undefined or empty string, depending on the context, that should be, right? So what's the value of this in this context? The value of this. Window? Anyone else? Null? Who said undefined? Undefined it is. All right. So we got window and undefined. Now, third question. Mark your scores. There's no prize at the end. Okay. Same exact code as the previous slide. Use strict, same function, but we're calling it off of the window object. Window? Anyone else? Window it is. Back to window, right? So this is actually code that we have in our code base, and this caught me because as soon as you use a bundler, you get use strict. So then all of a sudden you're running call on a function. The function exists, but then the value of this is getting passed as undefined, and then that'll just mess everything up. So this is some weird global stuff to keep an eye out when you're refactoring. The next thing we'll talk about is code splitting and my love of Webpack. A little bit of history. So like WordPress core, like we used to use Grunt as our build system. And there's nothing wrong with Grunt. It's just kind of a dumb task runner, right? And you set these tasks, run them in order. The problem that I had with it is that it was really slow during watch mode. So rebuilding all of our files, our JavaScript or Sass files, our images and all this stuff was taking like 7-8 seconds. And for a developer, that's way too long, right? 7-8 seconds when you're building. And the other thing was is using a Ruby gem Compass to compile our Sass files, right? So I didn't really see the need to have a dependency on a Ruby gem. We were using it, installing it on Travis and running all these automated tests, and it just was an extra headache we didn't need. So I figured it was about time we moved over to Webpack. And I really love Webpack because it's a lot faster, right? It can be a lot faster if you configure it. It allows us to not use Compass, right? So we have these Ruby gems that we no longer need, so we can use Node Sass to compile our stuff. And it has this concept of loaders and plugins so that we can modify our stuff as it gets pulled into the bundle. So as a specific example, so if you remember that WPMDB global variable that we have, so it's kind of like the WP global variable in WordPress core, same idea. So this thing's just hanging out in our code, and what would happen is plugins and add-ons would be hooking and adding on new functions to this thing. So when you're trying to track down a bug or trying to figure out where a function is defined, it could be anywhere, right? It could be in this file, it could be in that add-on, a plugin. It didn't make any sense. So I figured it was about time to figure out where all these functions were defined and put them into one place. And since we were using Webpack and we had Babel running, not that we need it nowadays, but Babel was added in there, I figured it was about time to kind of move to these ES 2015 syntax. And so put them all in one file, right? So we have all of these functions and all these are now methods in a class, right? But we have to make sure that this is backwards compatible, right? So now you have code that's calling these functions that have been defined everywhere, but now I've moved them all into one file. So how do we keep this so that it doesn't explode? Well, it turns out Webpack is there to the rescue. And what you can do is we'll go through this file. So you have import your class, right? So you're just importing it into a variable, pretty straightforward. And we have this WPMDB functions thing exists in the global scope, so it's defined somewhere. I think at this point where it's added to this file. Oh, and I should mention, this is our Webpack entry file. So this is the file where Webpack starts from and starts to split out its dependency stuff. So what I would do here is you just add WPMDB.functions. That's this global functions thing. Now we're just assigning it a new instance of this WPMDB common class. And because the ES 2015 class syntax is just a syntactical thing over JavaScript's existing object stuff, it's not a brand new thing, it's just kind of a syntactical sugar thing. This actually just works, which I was surprised about, but it actually does. And then we have this next section, which is this crazy looking import all function. But really all it does is you pass it a directory and it goes through and it includes each file that's not this common file. And this is a work in progress, keep in mind this is kind of, we're progressively migrating to these modules. And then we use this require context when we call import all. And this is a Webpack specific function that you get. And the cool thing about it is that you can use a regular expression. So what we do is we have an imports loader that we're passing as the first argument. We're going to assign the $sign to our window.jQuery because WordPress admin has that already there. And we're starting the source directory. And then we're going to recurse to each directory. And the last section is that regular expression, which allows us to match these files, right? So any files that match this extension, we're now getting chucked into our bundle. And that's it. That's the Webpack entry file. So typically with Webpack, you'd use an import or a require statement in your code, right, to include the modules that you need. But because our legacy code doesn't actually do this and we don't actually have that in place, it just makes sense to kind of iterate over each file in our directories and then pull them in. So that works really well for us. So the last section I'll go through is new JavaScript. I like to call it new JS because I don't remember what version of the ECMAScript is at now, ES 2018, 2015, 17, whatever it is, right? But it's kind of a no-brainer nowadays because we're all using bundlers for the most part, right? I'm definitely using a bundler. We have Babel, right, if we want to support these older browsers. So it just makes sense. So the couple of things that I'll talk about, one of them is not really super fun, but we'll talk about template strings and we'll talk about async await, which I really like. So template strings, this is kind of one of those low-level things that you kind of need to do when you're cleaning up code, right? We have a lot of strings that are added. And with these backticks now, with the new template strings, you don't have to use a templating library to make these fancy UI updates, right? You need to get in Mustache or whatever. We can just use the native stuff that comes with JavaScript. So that's something that's kind of an easy win. piece that I wanted to chuck in here. And then the next section I'll talk about is kind of my new favorite thing. And it's async await. And async await is really cool because it allows you to take your asynchronous promise-based JavaScript code and convert it to be kind of a synchronous looking. It doesn't actually change it, but it makes it a lot easier to read when you're just trying to quickly understand what's going on. So the two important parts here, right? There's this async keyword and this await keyword. Async just says this function is going to do some asynchronous stuff. And the newer specs, this is going to be, you can assign this block level, so you'll be able to say every function in this file is going to be asynchronous. But this is how we have to do it for now. And we have the await keyword, which is right before the AJAX, or the promise-based thing that you're waiting for, the asynchronous thing, right? And the next thing we have to do is wrap it in a try-catch block. So if you're familiar with JavaScript's promises, or the older kind of, if you're thinking about AJAX in particular, talking about like the error callbacks, those things just come for free. With async await for now, you have to wrap it in a try-catch so you can handle those errors. But it's really easy because once you get into it, it makes a lot of sense. So we define this response variable, and then we wait for this AJAX call to finish. And because jQuery's AJAX actually returns a promise interface, we can just wait for it. And that's really what the async await setup is about extending the promise-based, the inherit JavaScript version now. So we can just use the async await instead of using our promises, right? Chaining the thens and that kind of thing. And that just works, right? So then we wait for that AJAX call to finish, and then that value comes back and is assigned to our variable, right? And that's very synchronous looking, right? You don't have to worry about all these really deeply nested callbacks or these chained then statements, right? So I'm a big fan. And then you can just work with it, right? And then you can just keep working with that variable, or you can return it, and then you can work off of that promise. So just to quickly go over, so now we put out the dumpster fire, hopefully giving some ideas and tips about that. So understanding the code, right? Get a good understanding of how everything's set together and what the different pieces are, bits and pieces are. Get your test on. So if you can't get your unit tests put in place, see if you can use some of these UI tests, these higher level tests that allow you to actually exercise your application like a user would. And then the last part is refactoring, right? So we talked about refactoring global variables, how the weird value of this can change over time. Splitting up your code using a bundler, and some of the new JavaScript stuff that we can do that'll help clean up our code. And there's a lot of other new JavaScript, ES 2017 and up stuff that we can do that really makes a lot of the code easier to read. So that's about all I have to say. You can find the slides and some more information at deliciousbrains.com/loopconf. And I'm on Twitter at Pete Tasker. And that's all, folks.
Thanks, Pete. We do have some time for some questions. If anybody has questions they'd like to ask Pete about everything he's talked about, we'll go here.
One of the biggest problems that I face with refactoring is not the idea of doing that, but is sharing what's changing, why it's changing, and what is changing. So how do you handle that?
Changing and watching what's changing when you're doing
essentially making the whole team aware of the fact that you're changing something and the reasons why you're doing that.
Yeah, and I don't have an easy answer for that. We've talked about it internally on our own team, and it's basically, it seems like you need to keep it hands off. So you can kind of use your source control like Git. You can say this is the refactor branch, and then you can periodically merge things in. But I mean, other than that, it's somebody kind of has to take charge of that and then let everybody know, like, okay, I'm going to mess around with all this stuff. If you're going to try and mess with it too, it's going to lead to a whole bunch of merge conflicts, which we all love. So, yeah, that's basically what I've discovered. Yeah. Yeah.
So one of the things we've run into when refactoring is you got a few different devs working on it. They all have their own levels of ES 2016, 17, all their own little tricks they want to use.
Yep.
And so you end up with a lot of different code styles coming in. But if it's refactored, it's supposed to be all pretty and uniform.
Yep.
Advice for how to approach that, how to come up with a standard style that everybody understands and can agree to?
Well, I kind of touched on it a little bit, and I find that getting ESLint integrated sooner rather than later can really help. ESLint is cool because it allows you to specify your rules, so you can say how verbose you want to be or not. You can have like 3 rules and just say, tabs or spaces or, no comma dangles and that kind of thing. That's a good starting point. And then if you run it on your build or you run it on your, there's services that'll run it on your commit hooks, like on GitHub. It'll say, okay, this won't be able to merge because of the code style inconsistencies. So that's probably the best thing to do. I would say. Yeah.
More questions? Going once, twice. Let's give it up for Pete.
Thank you.
All right, so our next speaker is Mara Till, and she will be speaking at 2:55 in 10 minutes. So we'll see you then, and enjoy yourselves until then.